Hi, my name is N.Mau.
And my name is Natalie
We're
Nguyen.
both from Piedmont Hills High School and working under Dr. Suzette.
Online shopping has become an increasingly popular form of consumption that has exploded since the 2010s. However, the excess packaging needed to secure items for shipping has resulted in an enormous amount of waste. According to the U.S. Environmental Protection Agency, packaging materials make up about 30% of all waste in the U.S. In particular, plastic packaging makes up 40% of the world's plastic waste, which is detrimental given that plastic can take anywhere from 20 to 1,000 years to decompose. Foam, another popular packaging material, can take up to 500 years to decompose. And while cardboard and paper are technically recyclable, 56 of all cardboard and paper waste go to landfills every year. In a world full of packaging material options, there are seldom ones that are good for the environment.
From a simple video found scrolling on YouTube, our interest in mycelium-based material increased and might be the solution. Made from hemp hurd, a type of agricultural waste, and mycelium, the root structure of fungi, which is made up of natural polymers like cellulose and chitin, mycelium-based packaging is a more sustainable alternative to packaging materials like foam or cardboard. Mycelium-based packaging is highly biodegradable due to the fact that mycelium's polymers are easily consumed by microbes in the environment.
With the initial online research we did, we made the hypothesis that mycelium-based materials biodegrade more efficiently than traditional packaging materials due to enzymes that break down organic matter.
We wondered, how do mycelium-based materials biodegrade in comparison to standard packaging materials? And made two different experiments to test our hypothesis. The first step was to gather different packaging materials for our experiment, which were cardboard, paper, bubble wrap, styrofoam, and making the mycelium-based packaging. We used Grow Bio's Grow It Yourself kit to expedite our experiment. We followed the kit's instructions, which included adding flour and water into the material, resealing the bag, and letting it grow. After a few days, we regrinded the material to break up chunks and added more flour. Put the material into molds and left it out to grow until the mycelium was fully white. Afterwards, we removed all our packaging from their molds and put them into a clean garbage bag with a glass of water to finish the growth process. After a day, the finished material was baked at 180 degrees Fahrenheit for 4 hours until completely dried out, leaving us with various blocks of our fifth and final packaging material.
Our first experiment was a compost burial test. The aim for the compost burial test was to determine the biodegradability of each packaging material by deducing its total weight loss after 30 days. In order to conduct the compost burial test, we gathered and labeled 3 pots of the same size and filled each pot with 550 grams of compost for the 3 trials of our test. Afterwards, we cut and weighed out 1 gram of each material: mycelium-based packaging, cardboard, paper, bubble wrap, and styrofoam, 3 times for the 3 trials, which yielded 15 pieces of packaging material in total. Each gram of material was tied to its own string of yarn and buried into each pot of compost. This officially marked the beginning of the compost burial test.
In order to see the weight loss or gain of the materials along the way, we checked on the 3 trials daily by taking out all of the materials out of each pot and weighing them individually on a scale. To get a proper representation of the material's overall biodegradability, we left the material in for 30 days.
After 30 days had passed, we took out and analyzed the materials from the 3 trials. In trial 1, the mycelium-based packaging, cardboard, and paper weighed 3 grams. In trial 2, the mycelium-based packaging, cardboard, and paper weighed 4 grams. And in trial 3, the mycelium-based packaging and cardboard weighed 4 grams, while the paper weighed 3 grams. For all 3 trials, the weight of the styrofoam and plastic bubble wrap remained 1 gram.
Although the mycelium-based packaging ended up weighing, on average, 3.67 grams by the end of the test, the compost burial test still shows that the mycelium-based packaging yielded the greatest level of biodegradation. Putting a new 1 gram sample of mycelium-based packaging next to the compost burial test samples, we noticed that the samples we used for the test were much smaller in comparison. In addition, we found that the structure of the packaging feels much softer and less rigid than in the beginning of the test. Analyzing the cardboard and paper samples, we found they were similarly less rigid and looked worn, but did not decrease in size as drastically as the mycelium-based packaging did. In contrast, the bubble wrap and styrofoam looked, weighed, and felt practically the same as the new samples of the same materials.
These visual and sensory cues show us that the plastic and foam tests did not biodegrade at all within the 30 days, that the cardboard and paper had moderate levels of biodegradation, And finally, that the mycelium-based packaging had the highest level of biodegradation.
Our second experiment was a lime water test. The lime water test allows us to determine the biodegradability of each material by visualizing the levels of carbon dioxide each material releases when put in compost. However, we understand that compost releases carbon dioxide on its own due to the nature of the carbon cycle. So for this test, we had a control along with the 5 packaging materials. In order to conduct the lime water test, we began by adding 149 grams of compost into 6 lidded plastic containers. We placed each type of packaging material into its respective containers and labeled them. In order to make the lime water for the test, we added 1 teaspoon of calcium hydroxide into a glass filled with distilled water. We shook the jar vigorously for about 2 minutes before letting it sit and settle. After 24 hours, we sifted the lime water through a coffee filter and waited another day for it to turn clearer. Once the lime water was made, we placed a small plastic cup into each of the 6 plastic containers. We added 5 teaspoons of the lime water into each plastic cup, closed the lids, and waited 24 hours for the lime water to take effect.
After waiting another 24 hours to give the materials a chance to biodegrade, we found that all 6 samples of lime water had become some level of cloudy. Even then, the lime water test we conducted still shows that the mycelium-based packaging exhibited the greatest level of biodegradation. The sample of lime water in the control container was only slightly cloudy on the surface, meaning only a bit of carbon dioxide was released from the compost and a trace of calcium carbonate formed. The samples in the containers of plastic bubble wrap and styrofoam also exhibited a similar level of cloudiness as the control. In contrast, the samples of lime water in the containers of paper and cardboard were more cloudy, meaning more carbon dioxide was released and more calcium carbonate formed. The sample of lime water in the container of mycelium looked almost milky, meaning a lot of carbon dioxide released and precipitate of calcium carbonate formed. The container with the mycelium-based packaging exhibited the greatest release of carbon dioxide, meaning that it biodegraded most effectively in comparison to the 4 other packaging materials.
Through our tests, we concluded that mycelium-based packaging is the most sustainable and biodegradable packaging material. As online shopping continues to grow, eco-friendly packaging options should grow alongside it, and mycelium is a clear frontrunner in the race of sustainability. Staying conscious of your environmental footprint through simple things such as shopping in person to avoid packaging waste and staying vigilant in looking for reusable or biodegradable options for everyday use is crucial to help our Earth.
You can scan the QR code for the works cited or take a peek while it rolls through the screen. Thank you!